Okay, let's start off with this particular one. So, um, let's say D equals the GCD of R and S. So that means D divides R and D divides S. So that means D would divide R plus S, and D would certainly divide um, AR plus BS. But um, this piece here is 1, so that means D divides 1, which conclusion then is D has to be 1. You can do similar logic here. Let's say D equals the GCD of R and B. So that means D divides R, D divides B. So D would certainly divide R plus B. And likewise, it would divide multiples of each of them added together. I guess I don't really need to say this step here, do I? D would divide AR plus BS, but that means D divides 1, so D equals 1. And likewise, D equals GCD of AS. So there's a D there. Exists a D then that divides A. There's a D divides S, and there's a D that would certainly divide a linear sum of the two, but that linear sum is 1, so that means D equals 1. So basically what's happening here, you can think about it like this. If the GCD of A and B is 1, it means there's nothing you can take out from the A and the B other than the number 1 as a factor. And likewise, because the total here is 1, again, similar to, I think, like question 16 or something, there's nothing you can take out from R and S. So, like, the greatest common divisor here has to be 1 from each of these parts here. So, like, you're comparing A and S here. The greatest thing you could take out from them is 1, because this is a sum that's equal to 1. And then you do A. I guess you could do the same thing with A and B. I guess you know that already, though. R and B, which is the next one, and then R and S, which is the last one then. So it's kind of just like intuitively like the factorizing thing. Like say you have two numbers, like let's say 7 plus 9. And that's equal to the greatest common divisor then is 1, and you have a multiple of that and a multiple of that, and it's also equal to 1. There's nothing that you could factor out lambda and mu instead if this total up is 1. So maybe I'm not explaining that clearly, but I think this proof will do.